There are some more reactions of carboxylic acids. They are, first one is esterification. Esterification means formation of esters from carboxylic acids is called esters. How they are formed? When carboxylic acid reacts with alcohol in the presence of concentrated H2SO4, then we get esters and H2O as byproduct. Here some points are there. They are, here H2O is formed as byproduct. Okay. That H2O contains H and OH. Here the point is H comes from alcohol acid and OH comes from alcohol acid. Here in both cases OH and OH are present. H comes from alcohol, H comes from acid. OH comes from alcohol, OH comes from acid. We have to know those points. So what is the point here? If in the above reaction hydrogen is removed from alcohol, that means hydrogen is removed from here only, not from here, but OH is removed from acid. The order of reactivity of alcohols towards esterification is, and that means here H is, that means OH bond takes place. OH bond cleavage takes place in case of alcohol. So what is the order of primary, secondary, tertiary regarding OH bond cleavage? Primary is greater than, secondary is greater than tertiary. We discussed this point in alcohols topic, because here OH bond undergo cleavage. What about acids order? That means here CO bond will be broken. But as per rules, as per theory of alcohols, regarding CO bond cleavage, tertiary will be more than secondary, which will be more than primary. Tertiary greater than secondary greater than primary. That is order regarding CO in alcohols. But here this is not alcohol, this is acid. Here also order is same as in alcohols, that is primary greater than secondary greater than tertiary. Why? Because this is important point, because this H is replaced by this group, or we can say one more point, this OH minus is replaced by R dash O minus. This OH minus is replaced by R dash O minus. If suppose here bulky groups are present, then it cannot come easily to here. So what is the order here also? Primary greater than, secondary greater than, tertiary. That means this is the order of acids, not alcohols. That means if one alkyl group is present, it can easily come and attack here. If two alkyl groups is present, it is somehow difficult to come and attack here. That is the meaning of this one. So in both cases order is same, that is primary greater than, secondary greater than, tertiary. This is about esterification. Next one, formation of anhydride. Anhydride means removal of water, that is called anhydride. Suppose this is what acetic acid. When two acetic acid molecules, this is acetic acid, when two acetic acid molecules undergoes heating, then water will be removed. That means this OH and H, or this OH and H, then what will be remain? CH3CO, CH3CO. That means here CH3CO is there, CH3CO is there, 2 CH3CO, and 1 O will be left. This is called acetic anhydride. Next, reactions due to cleavage of COOH bond. Reactions due to cleavage of COOH bond. That means this total group will be removed from carboxylic acid when it reacts with some compounds. Among them, first one is reduction. Here, when carboxylic acids undergoes reduction in the presence of LiAlH4 or B2H6, this is important point. When carboxylic acids undergoes reduction in the presence of LiAlH4 or B2H6, that means what? Diborate. Then this is COOH converted into CH2OH. This is also an important point. When acids undergoes reduction in the presence of LiAlH4, which will form primary alcohols will be formed. Next, decarboxylation. Decarboxylation means what? Removal of CO2. Removal of CO2 is called decarboxylation. When carboxylic acids undergoes heating, then this CO2 will be removed, then which will be left? R and H, that means alkane. Here also this is also decarboxylation. We got this reaction in class 11. This is sodium carboxylate. When this compound reacts with NaOH and CO, this is what? Soda lime. Then this part will be removed. Which part? This part will be removed. That means Na2CO3 will be removed. Here also alkenes are formed. Next, suppose when sodium carboxylate, two sodium carboxylate reacts with water, when that means this is comes under electrolysis, then what happen? This CO2 will be removed, this NaOH will be removed, this H2 will be removed, then finally what will be left? Alkenes will be left. This is alkane, this is NaOH, this is CO2, this is H2O. So all these reactions comes under decarboxylation, because in all these reactions CO2 will be removed. If decarboxylation asked in exam, you can write either of the reaction. Better to write this reaction. If you write this reaction, then also you get, but this is specifically known as coal-based electrolysis, but this is also comes under decarboxylation reaction. Better to write this reaction. If you write any reaction, you can get full marks, but better to write this reaction. Next reaction is HVZ reaction. This is the last reaction. When carboxylic acids reacts with halogens in the presence of red phosphorus, then we get alpha halocarboxylic acid. Alpha means this is functional group. The carbon which is attached to functional group is called alpha. If halogen is present on alpha carbon, that is alpha halo. So what is the point here? If a carboxylic acid having alpha hydrogen, when it reacts with the halogens in the presence of red phosphorus, then we get alpha halocarboxylic acid. That reaction is called HVZ reaction. This is also one of the important reaction because this is named reaction. Next topic in this topic is acidic nature of carboxylic acid. This is aliphatic carboxylic acids. When our carboxylic acid loses H plus N, then it forms carboxylate ion. This carboxylate ion is stabilized by resonance. When carboxylic acids loses H plus, they form carboxylate ion. These are stabilized by resonance. See, when carboxylic acids release H plus N, then carboxylate ion is formed. This is stabilized by resonance. Hence, carboxylic acids are stronger than phenols. And of course, in case of phenols also, when phenols loses H plus N, there also phenoxyl ions are produced. There also phenoxyl ions are stabilized by resonance. But compared to phenols, carboxylic acids are stronger because, see here, reason is there. In phenols, the negative charge is present on less electronegative atom. In phenols, negative charge is present on less electronegative atom, that means carbon. But in case of carboxylic acids, the negative charge is present on only oxygen. Compared to carbon, oxygen is more electronegative. If negative charge is present on more electronegative, that will be more stable. Because of that reason, carboxylic acids are stronger than phenols. That is very, very important point. I repeat the point once again, listen carefully. Carboxylic acids are stronger than phenols. Why? When carboxylic acids loses H plus N, they form carboxylate ion. These carboxylate ion stabilized by resonance. In those resonance structures, negative charge present on oxygen atom only, so that they are more stable. So they are stronger than phenols. But in case of phenols, if they lose H plus N, they form phenoxyl ion. Those are also stabilized by resonance. But in such structures, that negative charge is present on carbon atom. Carbon is less electronegative compared to oxygen, so that they are less stable compared to carboxylic acids. Next point. If electron withdrawing groups present on benzene ring, then acidic nature of carboxylic acids increases. We know that the same phenomenon happened in case of phenols also. If electron with donating groups present on benzene ring, then acidic nature decreases. See, this is para, this is normal carboxylic benzoic acid, this is electron donating group benzoic acid. Para nitro benzoic acid, para-methoxybenzoic acid. This is electron withdrawing group. This is electron donating group. Here no group is present. So among these compounds, which is having more acidic nature, this one, because here electron donating group is present. Sorry, electron withdrawing group is present. So this is stronger than this one. Why this is stronger than this one? Here there is no electron donating withdrawing, but here electron withdrawing group is present. If electron withdrawing group is present, that will be less acidic. So this is more than this one. More means more acidic. Next, the effect of following groups in increasing acidity order is pH less than, I minus less than. That means what? If a CF3 group is present, then that compound will be more acidic. After that NO2, after that Cn, after that F minus, after that Cl, Br, I, least one is phenyl. This is the order of acidity, acidic nature when these groups present in given organic compound. Next one, note. See, when these points also very important. When toluene undergoes oxidation in the presence of KMNO4, we get benzoic acid. That means what happened? That all hydrogens removed by oxygens, but one hydrogen will be left. That is benzoic acid. This is ethyl benzene. When this compound also undergoes oxidation, then also we get benzoic acid. Here 2 carbons are present. Even 100 carbons also present, we get only 1 carbon in the product. That carbon forms carboxylic acid. Here 3 carbons are present. Then also we get only 1 carboxylic acid. So what is the point here? If benzene having alpha hydrogen, this is alpha hydrogen, this is alpha hydrogen. If alpha hydrogen, when that compound undergoes oxidation in the presence of KMNO4, then that compound forms benzoic acid. If alpha hydrogen is not there, see, C is CH3 thrice. Here no alpha hydrogen. This is substituent. On this carbon no alpha hydrogen. Then it cannot form benzoic acid. So this reaction does not occur. That means it cannot react with KMNO4. So what is the point here? If alpha hydrogen is present on benzene ring, when it reacts with KMNO4, that means when it undergoes oxidation in the presence of KMNO4, then we get which one? Benzoic acid. When benzoic acid undergoes nitration, then we get meta-nitrobenzoic acid. Why? Because this is the electron withdrawing group. When electron withdrawing group is present on benzene ring, then incoming electrophile attack at the meta position. Here also electrophile attack at meta position. But when benzoic acid reacts with NH3, then we get this addition compound. When it undergoes heating, then then H2O will be lost by leaving benzamide. That means same type of reaction takes place in case of aliphatic carboxylic acids also. This is aromatic carboxylic acid. When aliphatic carboxylic acids or aromatic carboxylic acids reacts with ammonia, then we get amides. They are aliphatic amides, here are aromatic amides. That is the only difference.